inscribed angles within a circle. So before we were looking at central angles. Now I want to look at an inscribed angle. Now I want you to know that there are a difference between the two. Okay, so in years past, people think that a central angle and an inscribed angle are the same. They're not the same. Okay, they are different. So an inscribed angle is an angle whose vertex is on a circle. Okay, so the vertex again is that point of your angle. It's on the circle. And whose sides contain chords of the circle. Okay, so if you look at the right there in that picture, point E is on the circle, right? That's your vertex. Now that angle is made up of two chords, ED and EF. Okay, that is an inscribed angle. Before, we were going over central angles. Okay, so central angles are the ones drawn from the center. 2 points out here. Okay, so do you see the difference between those two angles? How one is in the center and the other is on the circle. Okay. So with our inscribed angles, we have an intercepted arc. So in this case, with your inscribed angle DEF, your intercepted arc would be arc DF. Okay, so that's the arc across from that angle. So one that gets intercepted by those two chords. So we also have this inscribed angle theorem. It states if an angle is inscribed in a circle, then the measure of the angle equals half the measure of the intercepted arc. So if I know what the intercepted arc measure is, so again, looking at my picture here, if I know arc DF is 30. So say I know that that measure of that arc is 30. That means my inscribed angle, so this angle DEF, would be half of that measure. Okay, so that angle measure would be 15. So that is different than the central angle. What would the central angle's measure be? This angle right here from G to that intercepted arc. That would be 30. Okay, so do you see that difference? Don't get your central angle confused with your inscribed angle. Your inscribed angle is on the circle and it's half of that intercepted arc. Your central angle is from the center of your circle and is the same as the arc. Okay? Questions on that? All right, then we're going to look at some examples. So we want to find each measure for these three problems here. So number one, we want to find the measure of arc AC. So I'm looking for this arc right here. Okay, so I'm looking for arc AC. I know what my inscribed angle is. That's 36 degrees. So to find my intercepted arc, all I have to do is take my inscribed angle, which is 36, and multiply by 2. Okay, so the measure of arc AC is equal to 72. So if I know that arc AC is 72, what would its central angle be? Not that you need to do this part, but it would be 72. Okay? So, again, difference between your inscribed angle and your central angle. All right, next one. I want to find the measure of angle N. Okay, that means it's looking for this angle right here. Okay, so I'm going to take that intercepted arc of LK, which is 62, and we're going to divide that by 2 to get that angle measure is 31 degrees. Okay, then last one in this section here. We're looking for the measure of our QSR. So from point Q to point S to point R. So all the way around the outside there. Well, I know that my inscribed angle that intercepts that arc right there is 113 degrees. So what can I do with that to find that intercepted arc? Multiply by 2.
226.
Okay, so the measure of arc QSR is 226. All right, questions on those 3 problems? All right, then our next section here. If 2 inscribed angles intercept the same arc or congruent arcs, then the angles are congruent. Okay, so if your 2 inscribed angles intercept the same arc, then those angles are congruent. And I'm going to kind of show you that in our examples below here. Okay, so I want you to look at arc UV. Okay, so you see that arc there, UV, that I highlighted yellow? Well, it's kind of hard to see. I'm going to look for 2 inscribed angles that intercept that arc. So, moving up this way, okay, this angle that I highlighted pink here intercepts that arc, correct? Do you see that?
Yes.
Okay. Another angle that intercepts that arc, UV, would be angle VWU. Okay, so you see this blue one also intercepts that yellow arc that I highlighted. Since both of those separate angles, focus. Both of those separate angles intercept that same arc of UV. That means angle W and angle T have to be congruent to each other. Yes. They both intercept arc UV, the yellow one, right?
Yep.
So T intercepts that and W intercepts that. So they have to be congruent to each other. Okay, same thing with arc WT and angle WVT and angle WUT. Those 2 have to be congruent to each other. Okay, because they intercept that same arc. So, we're quiet, please. So, for numbers 4 and 5, I want to find the measure of angle U and the measure of angle T. Well, in order to find U is 30. So, since angle V is 30 degrees, and I know these 2 angles are congruent, U would be 30. Okay, then I want to find the measure of angle T. Well, to find the measure of angle T, first I want to find what x is. So they are equal to each other since I labeled those as congruent. So we have 2x plus 9 equals 3x plus 4. Okay, subtract 2x. Subtract 4. Okay, so x is equal to 5, but I do want to still find the measure of angle T. It is 19. So you plug in 5. Plug in 5 for x. So we have 3 times 5 plus 4. And that is 19 degrees. Okay, questions on how I did problems 4 and 5? All right, then I want you guys to do 6 and 7. Do problems 6 and 7.
Was she dancing?
What are we equalizing?
I'm so confused right now. How do you know which one? What's equal then? No, shit, you equal. When you say you didn't know, try to help me.
No, you teach me how to do this first.
How do you know which one?
Is the answer 14? Correct. This is answer 14. No, because we don't care about how many you're for angle A. Maybe for yeah, I don't have the issue. This is supposed to go to you.
You have to add 11 to the side.
I love being short.
So 11 minus 3.
Oh, that's my line. So it's 8.
Well, x is 8.
So you see these two? That's why it was
All right, looking at numbers 6 and 7, if I look at arc AD, okay, so this arc right here,
How do you know it's 80?
because I want to look at the inscribed angles. So my inscribed angles right now are this one, this one, this one, and this one.
But could you pick these?
Yes.
Okay.
So if I look at arc AD, looking at the angles that intercept that arc, that would be angle B and angle C. Okay, so since both of those angles intercept that arc, they have to be congruent to each other. No, quiet please. Okay, Okay, same thing with arc BC. Angle A and angle D both intercept that arc, so they have to be congruent. So to find the measure of angle A, I can set these two angles equal to solve for y first. So we have 6y minus 2 equals 5y plus 8. Subtract 5y. Add 2. Y does equal 10. So since y is equal to 10, I'm going to plug that in here. So I have 6 times 10 minus 2. That's 58 degrees. Okay, then same thing with angles B and C. Those two are congruent, so I can set their measures equal. So we have 6x minus 3 equals 7x minus 11. Subtract 6x. Add 11. X is equal to 8. Plug in 8 for x for the measure of angle C.
45.
And I do get 45 degrees. Okay, questions on how I found these? How I found which angles are congruent?